Okay, so there are a couple things I want you to write down just as a reminder today. We did kind of write them down yesterday, but it's nice to kind of have everything in one spot. So the main things I want you to know is your domain. What I like to say is it's your width. And you start farthest left and work your way right, and that's what keeps it least to greatest. Okay? Your range is your height. It's your Y, your up and down, okay? And you're going to start lowest and work your way up, and that's what's going to keep it least to greatest. Okay, we did kind of talk about this yesterday, but I'm going to kind of put it all in one spot too, just for y'all today. So discrete is when it's graphed with dots only, no lines. Okay, and you're going to use the brace. These are actually called braces. I know I call them fancy brackets, but if I'm being proper, okay, they're called braces. And you're going to do a list of numbers inside fancy brackets. Braces. Okay? Now, continuous is dots and lines. It can have both, and that's totally fine. So I want you to realize with continuous, you either use square brackets or parentheses, and there's different times for both. So we're going to talk about the two times. So you have square brackets anytime you have a solid dot or a solid line. Okay, remember, those represent when it touches that point. Okay, so anytime you have a solid dot or a solid line, it's telling you it touches that point. Okay? Now the time you use parentheses is when you have an open dot, an asymptote, which we'll talk about during our notes. Asymptote. It's a word I always have to sound out. And what was the other reason? Infinity, duh. Okay, so anytime you have infinity, positive or negative, you use parentheses. Now, another thing that you need to know is that closed dots always trump open dots. They always win. Okay, so if you have an open dot and a closed dot on the same line, you pay attention to the closed dot, not the open dot. Okay? Yes? Cool. Okay, so knowing that, I'll give y'all another second to write that down if you need to. Okay, we're going to keep going. So, looking at number one, what shape is that? A circle. Okay, does it have any open dots? No. Okay, it doesn't have any asymptotes. Like I said, we'll get to that in a minute, but there won't be one until I tell you. So we're going to talk about domain. So this is continuous. Now, is this a function or a relation only? Relation only. This one's super obvious because if I were to draw a vertical line, it touches more than once, so we know it's not a function. Okay? Now let's talk about domain. So let's think about one thing at a time. Domain, I said to start farthest where? Always start at our farthest left. What is the farthest left this circle goes? -3. Okay, and we're going to use square brackets here because we don't have any infinities. It doesn't ever keep going up, down, side, or side. Okay, we only have just solid line. And what's the farthest right it goes? There is your domain. That is telling me that everything between -3 and 9 is being used. Okay? Is there a solid line everywhere between those two lines that I just drew? Yeah, see how that solid line literally goes from one side to the other? So that is true. Now, what about range? What is my lowest point? So negative 4 with a fancy, or with a bracket, not a fancy bracket. Okay, and what's the highest it goes? 1, 2, 3, 4, 5, 6, 7, 8. 8. Be careful. I know counting those dots gets a little crazy. Okay. Any questions with that? You see how the line does go from here to here height-wise? It takes up every piece between those two lines we just drew. That's why it does everything in between. Okay, so let's look at number 2. Function or relation only? It's a function. I can draw a vertical line anywhere, and it'll only touch once. So that's perfect. It's a function. Is it hot in here? A little bit? I'm just so used to air movement in here. Okay, I won't make y'all cold. Okay, so let's look at domain. Domain is our side to side. What is the farthest left this goes? Does it ever stop going left? It has an arrow pointing left. So what would I use to represent never stop going to the left? What kind of infinity? Negative infinity. Okay, remember, infinities always get parentheses. Now, what's the farthest right it goes? Infinity, positive infinity. And infinity always gets a parentheses. Now, this is where this one gets a little weird. What about height-wise? Well, what's the lowest it goes? Does it ever go above that? No, everywhere is negative 4, and it's a solid line, so we are literally just going to use square brackets around the number negative 4. Because that is the only height this line ever reaches. Okay? Okay, looking at number 3, does anybody remember what kind of graph that is? Huh? Sine. It's geometry. I don't even remember. I knew it was one of those. I hate geometry, so I'll let y'all keep that for 9th grade. That's the only math grade I haven't taught, and I won't go there. 10th grade, whatever. Okay, so let's look at domain. Well, first off, function or relation only? It's a function. Oop, wrong one. It is a function because if I draw a vertical line, doesn't matter where, it'll only ever touch once. Okay? So let's look at our domain. It has arrows, so if it keeps following that pattern, is it ever going to stop getting wider? No. So what would I use to represent that? Negative infinity to infinity. Because it's going to keep going both directions forever. Now, height-wise, what is the lowest it goes? Negative 2. And what's the highest it goes? It's 2. I know it's confusing with these dots. Any questions with that? I will say for the worksheets where y'all are graphing, I changed them all to regular graphs, not these dot things, because these are terrible. I don't know if you're like me, but I look at those dots and they all start to look like one dot, and you're just cross-eyed staring at it. Okay, so let's look at number 4. So first off, is this a function or a relation only? Relation only. Okay, because if I drew a line here, it touches more than once. Okay, so it is not a function. So let's think about domain side to side. Now, this has an arrow down here. This has a solid dot, so that's not going to move, right? But this arrow means that this direction is going to keep going. So what is the farthest left this goes? Negative infinity, because we're going to the left. Okay, because of that bottom piece, it is going to keep going left. Okay, what's the farthest right it goes? Negative 2. And it touches, it's got a solid line, so we're going to use a square bracket. Now, what's the lowest this graph is going to go for range? Negative infinity. And what's the highest this graph is going to go? Yep. 6 with a square because it's got a closed dot. Any questions? Okay, so let's keep going. Number 5, function or relation only? Function. Anybody remember what kind of function that is? It's a parabola, but who remembers like what the parent function is called? That's the shape. It's y equals x squared, but what's the word? Starts with a Q? No. Quadratic. Yes? Y'all. Okay, it's fine. I forgive y'all. Okay, so domain, side to side, is that U ever going to slowly quit getting wider? Or is it going to get wider forever? Yeah, forever. It's going to super slow, but it's going to keep getting wider. So my domain is negative infinity to infinity. What about my range? What's the lowest this goes? It goes down forever, so it's negative infinity. Now, what's the highest it goes? 2. Okay, so here's where things start to get a little weird. And they're not as simple. They're still not hard, but there is a little more thought to it. Okay? I want to show y'all something. So if I have 2 pins, are those 2 pins touching? No. And then if I have another pin up here, are they touching? No, I'm holding it above. They're not actually touching, but does it look like one continuous line? Okay, so think about that. I'm going to bring that analogy up here in just a second. So first off, is this a function or no? Yes. Okay, it is a function. So when we're thinking domain, we're thinking side to side. If you look at this line, though, there's 2 pieces, right? Sometimes when there's multiple pieces, you might have multiple parts to your domain. Sometimes you don't. And we'll talk about that why in just a second. So, domain, side to side, does this go to the left forever? Yes. Now, looking side to side, it has a line all through here, but then it stops where? Negative 2. Is there any other point at negative 2? No, so it stopped at negative 2. Now, I have a question, though. If you look really closely, I know this one's really hard to see, and I don't know why, but that is an open circle. Did y'all see the, like, teeny tiny white dot in the middle of it? I don't know why we did it that terrible. The other ones are not that terrible. I'm really sorry. If it ever looked like this, y'all, and you turned something in, I would totally give it to you because it's, like, well, let's be a little more obvious. That's how I feel. But it is an open circle, so we're going to use a parentheses. Now, where does it pick back up? Side to side. What is my side to side? What's my width of that point? It's at 0, right? With a closed dot. And does it go to the right forever? Yes. So anytime there's a break in your line, you will most likely have a U. But not always, so that's where the range comes in differently. How low does this graph go? Negative infinity. Now, looking at just the one piece, where does it stop height-wise? But do you see there's another dot at negative 1? And doesn't it pick back up and keep going up forever? So, y'all, therefore, this covers everything. Remember earlier when I said closed dots trump open dots? See how that closed dot is in line with the open dot? So there's a point there, so it keeps going forever. Okay? That's what I was saying. If we were to look at this sideways, okay, just like I did with my pins, these pins aren't touching, but does it look like the line still continues forever? That's what that analogy is saying. If it was 3D and we looked at it, it didn't stop. Okay? Does that make sense? A little bit? It's okay to say no. Okay, what kind of graph is this? Discrete. Okay, so knowing that, we're going to use fancy brackets and have a list. Is it a function or a relation only? It's a function. None of those dots line up with the other vertically. Okay, so we know it's a function. But we're going to use these fancy brackets and we're going to list what x values these dots use. So what's that furthest left dot? Negative 4. The next one? Next one? 0, positive 1, 2, 3, 4. And we list them all inside fancy brackets. Now, one thing we didn't really do yesterday, but we talked about how with domain and range, especially with discrete, well, only with discrete, you don't list numbers more than once. So looking at our height, what's the lowest these points are? -2. How many points are at that height? 3. But do we write -2 3 times? No, we don't repeat the numbers. We only write it once. Okay, what's the height of the next ones? 0 and the next ones. So that's what we meant yesterday when we said we don't repeat numbers for domain and range. Okay, number 8, function or relation only? Relation only, because if I drew a vertical line, it touches everywhere. Now, domain, what's the farthest left it goes? 1, 2, 3, 4, 5, 6, 7. Yes. What's the farthest right it goes? Does it ever go right from there? No, so we have the single number inside the square brackets. Now, what about height? What's the lowest it goes? -2. With what kind of dot? Open, so we use a parentheses. Comma, what's the highest it goes? Infinity also gets a parentheses. Number 9 is what kind of graph? It's a function. It's also what? Discrete. Okay, so domain, what's the farthest left these dots go? -2. Is there one at -1? Then there's one in the middle at 0. There's another one at +1, 2, and 3. So this one doesn't have any heights repeating, and that's totally fine. Our lowest is -3, -1, +1, 2, 3, 4, 5, and 6. Almost done, and then I'll quit talking. Okay, looking at number 10, function or relation only? Relation only. Because of this vertical piece, that horizontal piece is technically that's a function, but we're looking at the two together, so this cancels out that function. Okay, domain-wise, what is the farthest left this goes? -3. And then, doesn't it take a break? That one piece is only at -3. And then it takes a break, so we use a U. And where does it pick back up at? -1. Parentheses or bracket? Parentheses, because it's an open dot. And how far right does it go? Look at it. I thought that too, but it has a solid dot. The arrow and the solid dot are just really close, which throws me off. If you look at my key, I did white out right there because I did the same thing. Okay, so it does stop at 10 with a closed dot. So this is where it gets a little funky again, is our range. There are two pieces. What's the lowest this piece goes? Now, I want you to realize this is a solid dot, which means that is a closed circle, okay? I know it doesn't have one there, but a solid line represents a closed dot, okay? So, I want you to realize height-wise, where does the whole thing stop? -1. Because height-wise, yes, it takes a break side to side, but height-wise, it never takes a break, Okay, and we are going to put a square bracket because there are solid dots, and remember, solid dots trump closed dots. Hello. Thank you. Thank you. Okay, looking at number 11, function or relation only. Don't look at the dash line. I'm going to explain that in a minute. Just look at this little like ramp. It's a function. Okay, that dash line is just there. Does anybody remember what kind of function this is? Just that little ramp. Starts with an E. EX. So it's exponential. It's fine. In my other classes is what we're learning right now, so it's like fresh in my brain. Okay, this is an asymptote. Okay, you might not remember what an asymptote is, but hopefully you remember that weird word. Okay, asymptotes are when it gets really, really close, but it never actually touches. Okay? So gets close but does not touch. It's like the annoying little brother of math. Okay, you know, your annoying little brother's like, I'm not touching you, but they're so close to touching you that they might as well. Okay, same concept here with an asymptote. Okay, so knowing that, domain-wise, okay, there's an arrow right here, so it keeps going this way, and an arrow, so it keeps getting wider. So what would my domain be? Negative infinity to infinity. Now range. What is the lowest this goes? If it never touches the asymptote, what is it getting really close to? What height is that asymptote? 0. But remember how I said asymptotes always get parentheses. So it gets a parentheses because remember, it doesn't touch. And the square brackets represent it touching that number. Okay? And then what's my highest this goes? Infinity. One more. Okay, function or relation only? Relation only. If I drew a vertical line, it touches twice. What's the farthest left this goes? -3, and it's a solid line, so we have a square bracket. And what's the farthest right this goes? Okay, range, what's the lowest it goes? Negative infinity, what's the highest it goes? Positive infinity, so it does go all real numbers. It's going to keep getting wider sideways. Okay. Any questions for me? Comments, concerns? Okay. So, I want you to see there is a practice. I also want you to know that this practice is for today and Monday. It's front and back. So, if y'all can finish the front, I'll let you take a break. Okay. Now, if you want to keep going, that's fine too. But if you can show me you finished the front, show me or tell me to come here or something, then I will let you be done for the day. Happy Friday. Okay, so here's just things to remember.